On a seemingly ordinary quiet morning in May 2025, a significant magnitude 6.8 earthquake violently struck northwestern Iran, without warning. The sudden tremor turned a scene of calm into utter chaos in a matter of seconds. The widespread devastation served as a stark and sobering reminder of the immense and relentless power lurking beneath our very feet, a geological force that has profoundly shaped Iran's landscape and its rich history. The critical question arises, could we have foreseen this event coming? The answer, unfortunately, not with the level of precision that we desperately desire. Despite remarkable advances in scientific understanding and technology, predicting with certainty exactly when and where a major earthquake will ultimately strike, still remains one of the greatest scientific challenges facing us today. The Earth's crust is an incredibly complex and tangled web of hidden stresses and fault lines, making precise and reliable earthquake prediction a nearly impossible task. For the millions of people living in these vulnerable seismic zones, the ongoing quest for more accurate and timely forecasting is fundamentally about survival, turning scientific knowledge into a protective shield against potential disaster. To truly understand the frequency and intensity of earthquakes in Iran, we need to zoom out, way out. We need to see the bigger picture, to see how the country is essentially caught in a vice, squeezed between two massive, relentlessly moving tectonic plates. This unique geographical position makes Iran exceptionally vulnerable. The Arabian Plate, driven by forces deep within the Earth, is constantly pushing northwards, grinding against the Eurasian Plate. This is a slow but incredibly powerful process. This ongoing collision is relentlessly crumpling Iran in between, deforming the landscape and creating immense geological stress beneath the surface. This constant pressure builds up immense stress within the Earth's crust, like a spring being wound tighter and tighter. The energy is stored, waiting for a release. This pressure doesn't distribute evenly. Instead, it accumulates along fault lines, the pre-existing weaknesses in the Earth's crust. These are deep fractures in the Earth, like the well-known North Tabriz Fault, a major player in the region's seismic activity, and the extensive Zagros Fold and Thrust Belt, a vast zone of deformation that stretches for hundreds of kilometers. The majestic Zagros Mountains are the visible scars of this ongoing tectonic collision, a testament to the immense forces at play. All of this combines to make the region one of the world's most seismically active, a place where earthquakes are a frequent and dangerous reality. Unlike single, clean faults that rupture in a straightforward manner, Iran's fault network is incredibly complex and interconnected, characterized by many smaller faults branching off from the major ones, further complicating the stress distribution. This intricate web of faults means that even relatively small movements can be capable of producing damaging quakes, posing a constant threat to communities. When a fault finally slips and overcomes the friction holding it in place, decades or even centuries of stored energy are unleashed in a matter of seconds, releasing tremendous power. This sudden release of energy sends seismic waves radiating outwards, violently shaking the ground and everything on it. In Iran, given this geological reality, it's not a question of if another earthquake will occur, but rather, where and when the next quake will strike, a constant source of anxiety and a challenge for disaster preparedness. The chaos of fault rupture makes earthquake prediction fundamentally elusive. We can track strain with GPS and identify active faults, but the exact trigger remains hidden. Foreshocks once seemed promising, but they're unreliable. Many big quakes have no warning, and most small tremors lead nowhere. The deep fault zones are a black box. We can't monitor every detail miles underground. That's why seismologists now focus on forecasting probabilities, not certainties. Instead of predicting a quake on a specific day, we estimate the chance of a major event on a fault over decades. This guides building codes and disaster planning, but doesn't tell people when to take cover. While pinpointing the exact moment of an earthquake remains an elusive goal, a true prediction is still out of reach for now. However, cutting-edge technology is revolutionizing the way we monitor earthquakes and understand their behavior. Extensive networks of GPS satellites and highly sensitive seismometers are meticulously tracking even the slightest tectonic movements and tremors in real time, providing invaluable data. Furthermore, artificial intelligence is now being employed to sift through vast quantities of seismic data, diligently searching for subtle patterns and anomalies that human observers might easily miss. Sophisticated early warning systems such as Shake Alert are designed to detect the initial, less destructive seismic waves and rapidly send out alerts, providing precious seconds before the arrival of the more destructive shaking. As renowned seismologist Dr. Lucy Jones wisely points out, while we can't predict the precise moment an earthquake will strike, we can certainly forecast the level of risk and proactively build resilience within our communities. The creation and utilization of detailed hazard maps, coupled with the implementation of smarter and more robust building codes, can significantly help communities better prepare for earthquakes and substantially reduce the overall risk. The field of science is continuously moving towards more accurate forecasting methods and more effective early warning systems, ultimately empowering people to take informed action before disaster strikes and minimizes its impact. Whether it's in Iran or anywhere else around the globe, comprehensive knowledge and thorough preparation will always remain our best and most reliable defense against the inevitable next big quake.